afternoon, everyone. I have to say that was an excellent pronunciation of my surname. People struggle. It's taken me 30-odd years to get it right, so great. So my name is Dr. Minoo Rathnasabapathy. I'm a research engineer at Space Enabled. Space Enabled is a research group at MIT's Media Lab in Boston. So, there you go. So space technology innovation is revolutionizing our industry and changing its ecosystem. We are on the verge of a new space race where technology and services are as diverse as they are innovative. But more often than not, I get the question, there are so many challenges on Earth, why do you want to go to space? But the ability of space to transform businesses and the quality of life today are more relevant than ever. So as a research engineer at Space Enabled, our mission is in advancing justice in Earth's complex systems using designs enabled by space. Space technology has a tremendous potential to bring societal benefits if we design it to do so. The Sustainable Development Goals, or SDGs, as I'm sure most of you know, were adopted by the United Nations in 2015 and are a comprehensive summary of what challenges we have on Earth today. And space technology is a tool that can progress towards the SDGs by helping government agencies progress towards their own SDG targets, as well as helping them to measure and monitor their SDG progress in accordance to the indicators. So there are 6 types of space technology that I want to highlight today. These include satellite Earth observation, satellite communication, positioning and navigation, space technology transfer, human spaceflight and microgravity research, and finally, inspiration through research and education. Now, many of us use space technology in our everyday lives, often without even realizing it. But there are those around the world who do not have equal access to or benefit from space technology. But so barriers remain that make it expensive, confusing, and oftentimes difficult for some users to apply space technology. And in the age of technological innovation, Space Enabled are working to reduce these barriers to make sure communities and countries have equal access to affordable and safe space technology. So our focus is on harnessing 6 research methods, namely design, art, social science, complex systems modeling, satellite engineering, and finally, data science. So the Space Enabled group utilizes these 6 disciplines in an integrated design approach in collaboration with multilateral development agencies, governments, as well as the private sector. We see ourselves as academic researchers as a bridge between entrepreneurial firms who are experimenting with novel business models, as well as already established public sector organizations. And the real benefit of these collaborations is sharing the unique knowledge between each of the sectors. So, I want to highlight one of these space technologies, which is Earth observation. So when we think of pictures from space, of the Earth, this is what comes to mind. This is an image taken from the International Space Station of Hurricane Florence as it's moving towards the US East Coast. But there are many other examples. NASA, the European Space Agency, the German Aerospace Center are just a few examples of many countries and space agencies around the world that operate Earth observation satellites. Here you can see a few examples of the NASA satellites that are orbiting the world every single day, taking data and measurements of the Earth, the land, the atmosphere, and the ocean. But there's even more to see if we combine satellite imagery with mathematical models and science. Here we're seeing the breathing of our planet. And more specifically, this is the global change in the chlorophyll of plants, both on land as well as in the ocean. So we know that satellite Earth observation already is extensively used, not just to improve our understanding of the environment, but also improve our decision-making processes when we talk about sustainable development. So I want to focus on one example of the collaboration we do, especially in developing countries. So Space Enable works with an entrepreneurial firm called Greenkeeper Africa, based in Cotonou, Benin. Greenkeeper Africa is part of a larger ecosystem, working with local startups, government teams, as well as already established companies. So Greenkeeper Africa harvests an invasive water hyacinth plant from the coastal communities of Benin. This horizontally growing plant multiplies and causes hazards to both the environment as well as the local population of these coastal communities by having a thick bed of vegetation. This reduces the quality of life for the local population by impeding the economic activities such as fishing, trade, and tourism. It reduces the loss of it reduces the biodiversity of the region, and it also increases the risk of flooding. Mats of water, as you can see here, is also an ideal bed for malaria-transmitting mosquitoes. So Greenkeeper Africa have come up with an innovative solution. They harvest these invasive water hyacinth plants and transform the plants into fibers called kits. These kits are 100% organic, and they have the potential to absorb 17 times their weight in oil. So Greenkeeper Africa is simultaneously addressing two challenges. One is to manage the invasive water hyacinth plant, and two, to deter industries from causing oil pollution, and if they do, then absorbing using these kits. So using the integrated design process that I talked about a little bit earlier, Space Enabled and Greenkeeper Africa are using satellite imagery to predict the patterns of the growth of the water hyacinth plant and make this information, especially the predictive information, available to local communities. So digital data from satellites can be shown in two ways. Firstly, in true color, which is what we would see if we had to look at it with our very own eyes. We can also combine it with different wave bands to see the satellite imagery using false color. And here you can see that the vegetation is highlighted in red, making it visually easier for us to see and detect from space. The resolution of satellite images is also an important factor to take into consideration. Here you see images from Landsat 8, which is a satellite that images the Earth every 16 days at a resolution of 30 meters. Sentinel-2, another satellite, has very similar spectral bands to Landsat 8, having a resolution of 10 meters. And finally, PlanetScope doves offer the best resolution of 3 to 4 meters taken daily. Now, although PlanetScope doves do have the best resolution, if we wanted to track trends of this water hyacinth, we would need to use a combination of all three resolutions and different satellite data. So at Space Enabled, we want to take it one step further. And here you see a normalized difference vegetation index, or NDVI, which is a simple graphical indicator that assesses the remote sensing data over a specific area, and it analyzes the live green vegetation in that area. I won't go too much into the mathematics of it all. I'm happy to answer those questions later. But what I will say is that when we apply the NDVI, we see the vegetation highlighted in red, we see land highlighted in yellow, and water highlighted in green. So we can also begin to see a time-lapse imagery of how the water hyacinth moves and drifts, as well as grows in this particular region. So highlighted here is the plant along a bridge infrastructure. And if we take a time-lapse image of this, we see the plant begin to aggregate and grow along the infrastructure. Another example is the water hyacinth along waterways. And once this horizontally growing plant multiplies, it can completely block the waterways, so you don't have access to the bigger lake and away from it. Another particularly problematic area is the growth in tributaries, which are narrow waterways and rivers that lead into a larger lake. Again, once this is blocked, there's no access in or out. And finally, another interesting area that we see is the growth of this water hyacinth along akajas, which are man-made fisheries made from debris. So what we hope to do with Greenkeeper Africa is develop these polygon maps. So essentially looking at where the vegetation is and how the vegetation will grow and drift over time. What we hope to do in the future is also make this a web-based platform, so providing the tools to the local community so they can not only access the space data, but they can also log in at any time to see a visual plug-in point like this, to then see whether they want to go into harvesting or whether they choose to do something else. So the growth of the water hyacinth plant is also dependent largely on a lot of environmental factors, such as temperature, salinity, the nutrient content of the water, as well as the local weather patterns. And by using sensors placed in the local waterways, we can track the environmental changes and see how they then contribute to the growth of the water hyacinth. So I'm an engineer and I love graphs, so I'm going to put this slide in and talk a little bit about it. So what we see here is a combination of the data that we've gotten from the satellite imagery, from the in-situ sensors, so the sensors that we've actually placed in the waterways, as well as, very importantly, the local contextual factors. So this is going and speaking to the local community about what their user needs are when it comes to satellite data. And this graph shows the annual growth of the water hyacinth from January 2013 to July 2013 to July 2018. And what we can see is that between the months of September to December is where there's a peak growth season in the water hyacinth. But what we can also gather is that every alternate year, so in this case 2014 and 2016, there is an additional peak in the growth of the water hyacinth. And this is then collaborated and coordinated with the local weather patterns that happen at this time. Space Enabled have gone even one step further to come up with a predictive agent-based model to see what decisions the local people of the community of Cotonou might take when they look at the economic activity of that region, given the economical, social, and environmental factors. So in this example, we've used utility as the economic benefit, and we've had discounted by their perceived risk, which is distance, personal preference, and the probability of finding the water hyacinth. So in this first pass model, what you can see is the blue dots representing fishing, the red dots representing the potential smuggling of petroleum, and the green dots that represent the harvesting of the water hyacinth. So we can see in month 10 and 11, which correlates to October and November of the year, the peak growing seasons of the water hyacinth, the local population deters from the smuggling of petroleum or fishing to go for harvesting of the water hyacinth. So space-enabled is really creating a future in which anyone and everyone can use satellite data to understand their environment. So I've talked about the Earth. What about space? The rising population of space debris is a growing concern in our industry. To date, there are over 29,000 space debris objects over the size of 10 centimeters. So here at Space Enabled, we're really rethinking the life cycle of satellite missions in order to reduce the number of space debris. And we're doing this by exploring modular designs that will allow us to reconfigure satellite missions and components, as well as replace those components in space instead of replacing them on Earth and then taking them back up to space. So how do we get to space? Well, traditional propellants are harmful to humans and they're expensive, and you essentially have to look like this if you go anywhere near them. So we are investigating the use of candle wax, otherwise known as as paraffin wax, as a propellant to operate the small thrusters of satellite missions. So candle wax is inexpensive, and as you can see, it can be held by humans without any harm being done. And if you're anything like me, you own about 12 candles randomly placed in your apartment with all good purposes, but are currently gathering dust. So the real benefit of this candle wax is that it also acts as a thermal insulator to protect satellites from temperature changes. So I end this note. After learning a lot today, I want to say that regardless of the industry or the sector that we're in, technology innovation is really opening up new channels, new markets, and new opportunities. But to fully embrace innovation for sustainable development, we need to start capturing, integrating, and utilizing quality data. And we really need to work collectively to ensure that we can reduce barriers, so no matter where you're from or what work you're doing, you have access to this technology and innovation for societal and sustainable development. So thank you very much for your time.